5, 6 is least common multiple. So we're going to be finding least common multiples to help us with our fractions for finding the least common denominator between two fractions, and they could also have variables, so that will be the add-on for today. So we're on the Reading to Learn page first. We're going to go over some definitions, and then we will do some examples. So what is a multiple, first of all? On your multiplication sheet, these are multiples. So if I count by that number, those are the multiples. So threes, the multiples are 3, 6, 9, 12, 15, and so on. So if you're looking at multiples and you're struggling with some of them that might be larger, you can use your multiplication chart to help you find some of the multiples. So that might be helpful. So a multiple is a product of a number and a whole number. Okay, so like the multiples of 4, we would start at 0 because 0 is a multiple of everything. 4 times 0 is 0. Then 4, 8, 12. You're counting by 4s basically because you're doing 4 times 1, 4 times 2, 4 times 3, and so on. Common multiples would be numbers with the same multiple. Numbers with the same multiple. So I can have 4 and 6 are my multiples, or my numbers, and I'm going to do the multiples. 4, 8, 12, 16, 20, 24, dot, dot, dot. Keeps going. 6, 12, 18, 24, dot, dot, dot. And they have some common multiples. I see one that's 12 and one that's 24, and if I kept going, there would be more. Now what I want is the least common multiple. So in here, my least common multiple, my LCM, is 12. That's the smallest multiple that they have in common. So it's the least non-zero, otherwise they'd all be zeros. Least non-zero common multiple. So when I'm finding common multiples in my head, I look at the larger of the two numbers and I just start counting by that number until I find one that the other one also goes into. So I'd start at 6, no, 4 doesn't go into 6, 12, yes, 4 goes into 12, I'm done. So when I have smaller numbers, I'll be able to do these in my head. The least common denominator is the LCD. It's the least common multiple of the denominators. So if I had 3/4 and 5/6 and I wanted the least common denominator of the 4 and 6, again up here the least common denominator would be 12. Okay. Let's say that I had a fraction of 2a, 1 over 2a, and 1 over a. If I wanted to make a common denominator, I see that they both have an a in common, but I need a 2 on the bottom one. So if I times them both by 2, I'd have 2 over 2a and 1 over 2a. So I can also make common denominators with variables. Okay. Flip it over to the study guide side. So these are the examples. The least common multiple is the least non-zero number that has a multiple of 2 or more given numbers. When finding the least common multiple of small numbers, list several multiples of each number until it is found. I would say do these in your head or use your multiplication chart to help you. And so what I would do is I would count by the larger number, because if it was 3 and 5, if I'm using this chart, I can use the chart or I can just count by 5s in my head, obviously. I could say 5, 10, until I find one that 3 also goes into, which would be 15. So 3 doesn't go into this, 3 doesn't go into this, but it does go into 15. You do not need to make lists like that. You can count in your head. Excuse me. All right, so when we find the least common multiple of larger numbers, it says write the prime factorization of each and multiply the greatest power by each prime factor used. So I don't love this method because it has the trees, and since I figured out the cake method, I think I want to try that. So let's try 24 and 40. So what they did was they made trees, and then what you have to do is you have to find the greatest power of each prime factor. So you can only use it once. There it is. There's the greatest power of that factor, and that's the greatest power of 5, and then you take and multiply all those together. So here's what I'm going to do. I'm going to make the cake, and you have to find a common factor for those two, and it actually doesn't have to be primes. It can be anything. So if I pick 8, that would be 3 and 5, right? So that can't break down anymore. What happens in the cake method is you have to multiply all of the factors. So you would have 24 times 5. 24 times 5 is 120. Is that what they got? Yes. So 120 would be the least common multiple of 24 and 40. Because I don't know, you could still count by 40s and say 40, 24 doesn't go into that, 80, nope, 24 doesn't go into that. Then you would say 120, and then you'd have to think if 24 goes into 120, and you may or may not realize that it does. So sometimes doing this might be the easiest thing when you have larger numbers. All right, so we're going to find the least common denominator for 8 and 6. So if you can do this one of two ways. You can count by 8s in your head. 8, 6 doesn't go into that. Does 6 go into this? No. Does 6 go into 24? Yes. So 24 would be your least common multiple, which would also be your least common denominator. They did the prime factorization way, where it's 2 times 3, you got all the primes, and so they said you pick the biggest power of each factor. So you can only use a 2 once, you pick the bigger one. That's 8 times 3, which is 24. But ones like this are probably easier to do in your head, okay? So I'm going to find the least common multiple of monomials next. So the first one, we're going to do the cake. If I have bigger numbers, to find least common multiple of numbers. So let's say that we have 18xy squared and 10x squared y. So I'm going to do the cake for the 18 and the 10. I'm going to use 2 because I can't think of anything else right now. That would be 2 times 9, and this one would be 2 times 5. 5 and 9 don't have anything in common, so that means I'm done. And I'm going to multiply all of those numbers together. So this is 45 times 2, right? So we're going to times all of these together, and we're going to get 45 times 2, we're going to get 90 for my least common multiple. All right, so I found that I used the cake to find the least common multiple of the numbers. Then for the variables, I'm going to use the greatest power for each variable. Okay, so if I look at the variables, I have an x and an x squared. I got to use the x squared. I got a y squared and a y. I use the greater one. So I have 90 for the numbers, x squared for the x's, y squared for the y's, and you use every single variable. Even if there was an extra variable, like if there was a z here, you would still use the z because that's the biggest of the z. You have to use every single factor, every single variable, and if you have multiple variables, you use the greater power one. Okay? All right, so let's try some. For 3 and 6, I'm going to start counting, and you always start counting by the bigger number. So 6. Does 3 go into 6? Yes. So 6 is it. 4 and 9. Count by 9s. Or look on your sheet. 9. Does 4 go into that? No. No. Yes. 4 goes into 36. So 36 is my least common multiple. Start counting by the 15s. 15, 30. 10 goes into 30. You're done. Till I get bigger numbers, I'm not going to worry about the cake method, if I can do them in my head or if they're on here. So I've got 14s and I want to use 6. So I'm going to keep going until I find one that 6 goes into. There it is, 42. Count by the bigger number till you find one that 16 also goes into. And if you can't think of one that 16 goes into, then you can do the cake method. So I'm going to do the cake method for this one, 16 and 20. So let's do 4. That would be 4. That would be 5. Okay, so now I multiply all the factors. That's 20. 20 times 4 is 80. I don't know if I would have realized going across the 20s that 16 goes into 80, so that's why I wanted to try the cake method for that one. For 21 and 49, I don't know, I don't really want to count by 49s and it's not on my green sheet. 3 goes into both of them, so now I have to multiply these. So that's 49 times 3, because you can do it in any order you want. That would give me 27. That would give me 147. I'm not sure I would have known that by just counting by 49s. So that's why the cake method helps with bigger numbers. I'm going to count by the 6s. So I've got 6, 12, 18, 24, 30. And then you have to pick the biggest power, and that would be x, because they're both exactly the same, but you can only use one of them. Counting by 25s would be 25, no. 50, no. Does 15 go into 75? Yes. So it goes into 75, and then I have 2 B's here. One has 2, one has 3. We're going to use the one with the bigger power. 12 and 18. I'm going to use, I don't want to count by 18s. Or you can also use your multiplication table. So I'm going to say what goes into here. 3, 6, and 4. Uh-oh, I got a 2, which would be 3 and 2. So every one of those I need to multiply together. So that's like saying 6 times 6, which is 36. I've got an x and an x to the 4th. I use the bigger one, x to the 4th. Least common denominator, I want to just do the bottom numbers. So with 44, I count by 44. 44 is first. 11 goes into 44. Count by 10s. 10, no. 20, yes. 4 goes into 20. 16 and 20 we just did. Count by 20s. You can also look here and go across and be like, not sure. Oh, there it is. 80 goes. So that one is 80. Squeeze that in. This one here, there's only one number, 4, so you have to use it. And you have to use every variable. If there's multiple ones, you use the bigger power. So I have to use the s and I have to use the t. I won't use that t. I have to use every variable, so I use a. You got a b and a b squared, use the b squared. I have to use every variable. I have an x and an x squared, use the x squared, and there's a y cubed. You have to use every single factor or every single variable.